morning. Bom dia, Portugal. Ah, está tudo bien? Está tudo bem? Sí, great. Okay, you're looking good. You're looking awesome. Yeah, Portugal is on a roll, I think. I mean, first the Web Summit, then Singularity University officially coming to Portugal, then this event. If this continues, I think really then Portugal will be the Silicon Valley of Europe. Don't you think? You're already on the West Coast. I think that helps. Awesome, yeah. So we all know that this is part of a bigger trend, a bigger transition. We call it digital transformation. And my job right now in the next couple of minutes is to find out what kind of role that AI, artificial intelligence, Inteligência Artificial, I think, what kind of role that plays in digital transformation. Because usually when we hear the term digital transformation, and believe me, it will be mentioned a lot during this conference, usually organizations mean that they look for something that they already know, something that exists, an existing process, and they try to add digital, and they call it digital transformation, right? So in the past, people had to write letters, but now we have a web form. Digital transformation. Yeah, that's true, but it's not really innovative now, is it? So perhaps when we look at digital transformation, we shouldn't focus on digital. The emphasis shouldn't be on digital. It should be on transformation. Because the moment something is digital, it loses the limitations of the physical world. So for example, let's look at the digital transformation of entertainment, of movies, of films. Then in the old days, we had VHS, and then digital transformation. Now we have DVD. That's not really it, is it? So why not look at a company that we all know that did a great job in digital transformation? Of course, I'm talking about Netflix. Netflix used to send around DVDs in envelopes by mail. Can you imagine that? So very physical stuff. But then they thought, wait a minute, the D in DVD stands for digital. Why are we not streaming the content, making it universally accessible for everyone with an internet connection? So what they did was they offered their content streaming. They turned it into data. And the moment they made this jump, so from digital to data, they went from data to information because they knew exactly who was watching what, in what part of the world, and how or he or she felt about it. So they went from data to information. Well, I dare to say that most organizations, most companies are data rich, but information poor. Yeah, some of you are already whispering it. Why is this? Because most companies are still focusing on digitization. Perhaps we can add more data. Perhaps we can ask the zip code, the postal code of our customers. Yeah, let's do that. Why are we doing this? I don't know, but we need more data. No, we don't need more data. We need better data, and we need insights. So you make the jump from data to information. And this isn't AI. This is just analytics, right? But the moment you have made this jump, then perhaps you can apply machine learning. You can apply an algorithm to look at all the historic data, all the insights that you gathered, to come up with a useful tool. And this is what Netflix did. They hired not people who were good at stuffing DVDs in envelopes. No. They hired data scientists. Could you put your hand in the air if you consider yourself to be a trained data scientist? Ooh, 7. I love you guys. Yes. And girls, of course. All right, but this is what Netflix did. They hired a bunch of data scientists who gathered the data, they looked at the insight, and they tried to come up with an algorithm, a computer model, to look at all the historic data and then predict what someone would want to watch next. And they gave it a name. Of course, every algorithm, every cool algorithm has a name. They named it Cinematch. And it was okay. But at the same time, Netflix knew people always work somewhere else. Something spectacular. And I think this is the true innovation of Netflix. What they did was they organized the Netflix Prize. Could you, by show of hands, tell me if you've ever heard of the Netflix Prize? Okay, these are the data scientists plus these two guys. Awesome. So what they did, basically, they said, hello world, we're going to give you all of our data, anonymized, of course, anonymized. We're going to give you all of our historic data. And the first team that can build a better model than our Cinematch, they will win the Netflix prize. So if you can predict better than 10% than our current model, what someone would, you will win the Netflix prize. Do you have any idea what this prize, this reward was? A year's subscription of Netflix. Yeah, that's a very Dutch answer, I have to say. No. They said, if you can beat our algorithm with 10%, you will win $1 million. I should say $1 million. Yeah, that was the reward. Well, that got the attention of the world. 40,000 teams all across the world joined this online competition. Because that is how Netflix organized the Netflix prize. It was an online competition. So 40,000 teams downloaded the data set. They wanted to know what the data looked like, how they organized it. And 12,000 of these teams actually uploaded their results. Because this is, I think Netflix did it brilliantly. What they did was they basically supplied all these teams with a training set, training data. And I've dumbed it down a little bit. It looks something like this. It's a very large Excel sheet with one column with all the movies, all the content that Netflix had in their stores. And the columns represent people, fictional people. Her name isn't really Alice, etc. And on a 0 to 5 rating, how much she enjoyed the content. So, for example, Alice had watched the movie Love at Last. And for her, that was life-changing. Yeah, she gave it 5 stars. And for example, Bob, he watched the movie Cute Puppies of Love, and he's also a sucker for rom-com, so he gave it 4 stars, right? So this is how the data looked like. And the challenge of these 40,000 teams, of these data, these hackers, these nerds, these coders, these developers, you guys and girls, their challenge was to find out patterns were those numbers. So looking at these recommendations, could you predict if Alice, for example, would love a different movie? So you could say, well, she is very into romance, not very much into action. So you have a 2-dimensional graph, right? X and Y axis. Or you could find all sorts of other ways to classify this content. So you could predict, for example, how much someone would like other pieces of content. But the challenge, of course, is how do you know if you're doing the right thing? How can you validate this? So Netflix also gave away another data set. It is the test data. So for example, let's see, they knew that Alice had watched Cute Puppies of Love and that she had gave it a 3-star rating, but they didn't tell the teams, right? So the teams had to guess whether or not she gave it a 1, a 2, a 3, a 4, or 5. And all the teams that gave it a 1 or a 2, they would drop in the tournament. And the teams that would say, well, we think it's a 3, they would actually come in the top 10, for example. So the teams knew what was expected and how they were performing. It took 2 years for one team to actually beat Netflix's own algorithm by 10.5%. 10.5%. Actually, it were 3 teams. Collaboration is the thing, you know. So 3 teams combined. This is why it's a crazy name. Bell Course, Pragmatic Chaos. 3 teams together, ensemble learning, were able to beat Netflix's own algorithm, and they won the Netflix prize. As you can see, this is Reed Hastings, one of the most richest people in the United States. He's laughing and giving away $1 million to this team. There's only one catch. The teams gave away the money to charity, and Netflix never used the algorithm. What? Wow, that's $1 million down the drain. Why do you think Netflix never used the algorithm? Yeah, okay. I'll give you 3 reasons why Netflix didn't use the algorithm. One is, okay, so the data was anonymized, but if you know anything about data, you know that anonymized doesn't exist, right? It's pseudonymized, for example. And there were some teams who say, okay, so Alice doesn't really exist, but let's go on imdb.com and see if we can find someone who looks a lot like this Alice so that we can find out what her taste is and we can fill in the blanks. So some teams did it. They were hackers. They were very smart, but it was against the rules. So Netflix, which is an American company, was afraid of a privacy lawsuit, and they didn't dare to use the algorithm. We can understand why, right? The second reason is that Netflix considered this algorithm, these 3 algorithms basically, to be too complex to embed into the current IT infrastructure. This is not true, I'm just saying to make you feel good. It's not just in your organization, this is everywhere. And the third reason is, of course, some of you were saying this already, 2 years is a long time. The whole world had changed. Netflix had abandoned the 5-star rating. You know why? Because if you ask people, so what do you think of Schindler's List? 5 stars, okay. And Dumb and Dumber 2 with Jim Carrey, 1 star. Well, in practice, everybody would watch Jim Carrey and nobody would watch Schindler's List. So there was a lot of noise in the data set. And now Netflix had real-time information. Streaming is real time. So people who would watch a movie and then after 2 minutes say, nah, that is a signal, that's not noise. Or people who would watch the same movie 3 times in 1 month. That's a signal, that's not noise. So machine learning is all about finding the signal in the noise. By the way, I see a lot of people standing in the back. I have still seats over here. I don't mind if you would walk up here and fill these seats. There are like 23 of them. There are 15 over there. Please don't be shy. This is Lisboa. Come on. Yeah, there are seats also there. Make yourself feel at home. Bom dia. So, machine learning is all about finding a signal in a lot of noise. But this is also the reason why Netflix now can honestly say, we know what you want to see next. It's their core asset. And this is a service that hadn't existed in the old world, in the physical world. It is actually a new service. So they don't see data as a byproduct, digital transformation, no. Data is the product. And this is why Netflix algorithm right now is currently validated at $1 billion. That's a lot of money for a few lines of code, right? A lot of money for some math. But this is something that I think, and every time I say Netflix, I actually mean your company, of course. And I'm not talking about films or movies. I'm talking about your products or your services. So we shouldn't be afraid of machine learning. No, we should embrace it, because it is like a power tool to give our customers exactly what they want when they need it. And after me, Matteo Colombo will take some time to actually dive in what this means. So how is AI being implemented in enterprises all across the board? But this is my key learning. We shouldn't fear it. We should use it to delight our customers. The only thing we should fear is irresponsible use of machine learning, right? And this is why you see all these books come out. These are basically long lists of situations where the algorithm was biased or racist. Oh, and we say, that's so bad. We blame the technology, but that's not the real story, I think. Right? Because let's be honest, humans are flawed. We all have our shortcomings, right? People have prejudice. I mean, racism has been part of society, a huge problem of society for ages. Let's not blame the technology. Let's use the technology in a responsible way. And then you have facts, fairness, accuracy, confidentiality, and transparency. So do not blame the algorithm, no. Use the algorithm to actually trace the bias, find the racism, find the inequality, and then use machine learning to eliminate it. So we can actually use machine learning to correct for our own biases. But blaming the algorithm isn't the right way. It's basically looking in a mirror and blaming the mirror for the fact that your hair isn't very good that day. And this is a science. Some people think that data is all about art. It's about writing a few fancy lines in Python. No, it's actually data science. You have to know the difference between correlation and causality. This is from my favorite website. It shows the number of divorces in Maine throughout the years, and also the sale of butter, margarine, in the same years. And then you can see it correlates perfectly. And I think some hacker somewhere in Silicon Valley would actually think, hey, that will make a great app, right? A Tinder for butter or something, I don't know. But then you're asking for big problems if you don't know the difference between correlation and causality. Again, it's a science. The C, in fact, stands for confidentiality. And of course, we all know GDPR. We thought it was going to be a hassle, but actually GDPR, data protection, it appears to be a blessing in disguise. I truly believe that Europe is showing the world that you can actually protect your customers, that you can protect your citizens while doing machine learning. And the T stands for transparency, and this is the most tricky one. Because in the example that I gave you about Netflix, that's very much to the right? That's just basic high school math. We can understand linear regression. We can understand decision trees. These algorithms, yeah, we understand. We can explain them. But the more you get to the left, the more accurate these algorithms get, the harder time we have to actually understand what's going on under the hood. So, for example, neural networks, they can deal with unstructured data. So the Netflix competition, it was an Excel sheet. Okay, we understand Excel. But if you look at a JPEG or a PNG or a .mp4, we don't know what the hell is going on in the code, right? It's just a bunch of ones and zeros. Well, neural networks, deep learning can actually deal with those kinds of data as well. How many of you actually know how deep learning works, what it is and what it's not? Okay. Same guys again. Okay. We have to talk. So by now you know that artificial intelligence is a field of science. It is a search. It is trying to program machines to be smart or intelligent. And machine learning is a way to do that. Machine learning basically is a way for a machine to learn from examples, right? The Netflix competition, the machine, the algorithm learned from data. It took it as examples and then it said, okay, so I think I know what's going on. Deep learning is a subset of machine learning, and it can deal also with unstructured data. For example, if we look at a photo to the left, it's a raw image, all these pixels. And then in the end, there's the output. It basically says what's in the picture. And it does so by applying mathematical function in different layers. The more layers there are, the deeper the network. This is why it's called deep learning. So every layer is specialized in one element of figuring out what's in the picture. So if you show it a photo, then it will go through all the layers. And in the end, it will say, aha, I used to think it was an airplane or a truck, but doing all the math, adding up all the results, I think with high confidence that this is actually a car. So what this means with deep learning, that you cannot just do it with pixels, you can also do it with audio or video. Basically, this means that computers now have senses. They can look in the world and tell you what's going on. And for some people, this is frightening. They say, oh my God, so this is stuff that was reserved for humans only. And now computers do it as well? Yes. And this is good news, because there are so many situations in which you would want a machine to do something like that. For example, here in India, this is a photo of a hospital. As you can see, people are lining up, they're queuing up, they're waiting because there aren't enough doctors. There aren't enough eye doctors, ophthalmologists. And this is bad news because these people fear that they might be suffering from an eye disease. It's called diabetic retinopathy. Well, if you or I have it, there's nothing to worry about. We go to the doctor, he says you need surgery, and then we're fine, right? In Europe, we're fine. In India, 40% of the people who have this eye disease actually turn blind. They lose their sight because there aren't enough eye doctors to look at the photo and say, you need surgery. So what does it look like? Well, basically, this is a photo of the back of the retina, a photo of the inside of your eye. Anyone can take such a photo. And they showed these photos like 50,000 of them, of healthy eyes, of which a medical doctor, a professional doctor, had said, this is a photo of a healthy patient. And they showed it to a deep learning model. And in the end, after these 50,000 photos, they asked the model, do you now know how a healthy eye looks like? And then the algorithm said, yes. This is not true, but I just think it's funny that an algorithm would say, yes, boss. So what they then did was find 50,000 other photos of which a medical doctor, an ophthalmologist, had said, okay, this is bad news. You can see the hemorrhages over there. This is a diseased eye. They showed 50,000 of these photos to the algorithm, to the deep learning model. And then they asked the model, so now you know what a diseased eye looks like? And the algorithm said, yes, boss. And then the magic happened, of course. They showed it a photo of a new patient. And they didn't say whether or not it was diseased or it was healthy. How accurate do you think the prediction of the algorithm got? You're very optimistic. The right answer is the algorithm had it right in 95% of all situations. There where the trained doctor, the ophthalmologist, had it right in 91% of the cases. I'm not trying to diss the ophthalmologists, the eye doctors, because I think these people are close to holy. There just aren't enough of them. So this is not about displacement. No. This is about scaling expertise, right? Scaling expertise to places where it's needed the most. So for example, if usually this guy would have to travel for 12 hours to get to the nearest hospital, right now he can just take a photo of his retina, upload it to the cloud, and within a second get back, you're fine, you got nothing to worry about, or I think you should indeed get into that bus and drive all the way to the hospital because you need surgery, right? So this is about saving lives. This is about people not turning blind. So I think we shouldn't fear our future with AI. We should use it. We should shape our future. This is why this event is called Building the Future, right? We don't lean back. We actively co-create this future. And this is why we're here in Portugal. You have the passion. You have the people. You have the skills. The only thing you could say is, well, we don't have the technology. Well, I'm here to tell you, there is technology out there. It's already out there. I don't expect you to write your own algorithms. I mean, if you go online, Microsoft has a very proficient education platform where you can learn all about the basics of artificial intelligence. And if you want to get your hands dirty, you can even try out their machine learning suite. I mean, obviously you're here, so you're already hosting, perhaps with Azure. They have all these great plugins. You just drag and drop, and you can apply machine learning to your data. Technology is not the excuse. It's already out there. And if you're not hosting with Microsoft, AWS does the same. Amazon in their cloud suite. Just plug it in. Just experiment with it. See if you can get a correlation and then understand the correlation. Google even open sourced all the knowledge that they had, everything they knew, they learned about machine learning. They bundled it into TensorFlow, and it's now open source. This is basically the Swiss Army knife for deep learning. So I'm counting on you guys to actually take part, to play your role in building this future. Not fear AI, but shape AI, because AI isn't finished. It will never be finished. Remember how accurate the algorithm got? It got to 95%. So that's still 5% to go. How do you solve such a thing? Because the data is there, the computing power is there, the algorithms are there. How come it doesn't get better than 95%? Well, these are situations that we call corner cases. These are situations where the machine says, I don't know, tell me, is this a chihuahua or a muffin? I don't know. And then you say, it's a chihuahua. Okay, I think it's a chihuahua. No, it's a muffin. Oh, okay, it's a muffin. No, it's a chihuahua. This drives them crazy. This is the nightmare of a deep learning model. So how to solve it? How can you solve this problem? It isn't more data. It isn't more computing power. It isn't more math. We need humans. This is why you see this thing appear on some websites. This is the CAPTCHA. And of course, some of you are saying, no, 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 Jim, this is because you have to prove that you're not a robot. Google wants to know that you're not a robot. Google knows you're not a robot. They see it on the way you move your mouse across the screen, but they misuse this perception to have you train their algorithm some more. So they say, okay, we just want to make sure you're not a robot. Please tell us which is the muffin and which is the chihuahua. And this is why most of these CAPTCHAs are actually showing you situations in traffic. Yeah, right? Okay, we're going to show you a traffic light with bad lighting. What are you doing here? You're training the self-driving car. Ladies and gentlemen, we're all working for Google, and nobody gets paid. But it's so confusing to be an algorithm in these days. Yeah, I love food bloggers, you know. Yeah. I have something with dogs also. Hot dogs, yeah. Or legs, still not sure. My last example, you shouldn't look too long at it, but it's so yes, the future is bright. We're building the future. AI is going to be a huge part of it. But please, ladies and gentlemen, let's keep humans in the loop. Obrigado. Thank you. Thank you very much. Obrigado.